All right, turn to example 2. This time that's 6 inside the function. Horizontal stretch or horizontal compression. This would be compression because you would multiply x by 1/6. Remember that? It's always the reciprocal in the inside of the function. So again, off to the side, I'll do a quick sketch of cos. I'll label my axes family. Take my period, divide it into 4 sections. Maximum of 1, negative 1 is a minimum. Cos graph starts at a maximum. And you're going to hear me say this a lot, right? As a shortcut for graphing cos, that cosine graph starts at a maximum. You'll hear me say a sine graph starts in the middle going up. So this is our normal cosine graph. I'll label it y equals cos x. And what's going to happen is we are going to compress it, squish it towards the x-axis. So this value that we normally had as our period of 2 pi, can you see that 2 pi would get multiplied by 1/6, and you would end up with 2 pi over 6. And our new period, you could reduce this to pi over 3 if you like, or leave it as 2 pi over 6. That's our new period. Now I need to do that with each of those 4 numbers that are my axes family, but you're going to find, if I divide this into 4 equal sections, instead of multiplying each of them by 1/6, which isn't hard, you'll probably use the following shortcut. If I know the period is 2 pi over 6, the middle one is going to be the next easy one to figure out because it's going to be half of that. Take 2 pi over 6, multiply it by half, and I would get pi over 6. Then I could find the first one, because the first one is going to be half of this one. If I take pi over 6 and multiply it by half, I will get pi over 12. Then for the third one I find by just counting. If the first one is pi over 12, and they're all equally spaced, this is 1 pi over 12, 2 pi over 12, this will be 3 pi over 12. And you can leave it like that, or you could reduce it to pi over 4. Either is fine. So what we're going to find is when we're labeling our new period, because of our horizontal stretch or compression, we're still going to divide it into 4 equal sections, just like we had our axes family in 4 equal sections. We're going to label each of those sections. Our amplitude in this one is still 1, so our maximum and minimum are still positive 1 and negative 1. We're drawing a cos graph. A cos graph starts at a maximum, then it goes to center line, then to minimum, then to center line, then back to maximum. And so quite quickly, we were able to graph y equals cos of 6x. Part B, we're going to think of the same thing with a tan graph. That 2/3 is inside the function. This time we'd have a horizontal stretch. We're going to multiply our x values by 3/2. You're going to think about your tan graph. Think about your axes family. You would have an asymptote at pi over 2, 3 pi over 2. Also in the negative direction. At negative pi over 2 and negative 3 pi over 2. Yes.
Why do we have to graph the negative section of tangent? We're not graphing the negative section of sine and cosine.
True. And technically, you would only need to have one period. It's nice to show that it continues and repeats itself. And especially because the pattern looks like an x cubed graph, it's nice to have this middle section go from pi over 2 to negative pi over 2. Yes, I could save myself some time and maybe only draw 2 of them. But if I'm drawing 2 of them, I like to make it symmetrical on either side. It really doesn't matter, okay? You could technically have only one period and that would be enough. So there, I did a quick sketch of what tan was originally. I need to multiply all my x values by 3 over 2. So what is that going to do? I'll draw it here. We are going to find out what is going to happen to each of my x-intercepts and to each of my asymptotes. We are still going to have an asymptote here, another asymptote here, another, and on the way back, one there as well. And we're still going to have these points in the middle. But if this one originally was at pi, and I'm multiplying my x values by 3 over 2, does it make sense that this one is now at 3 over 2 times pi, which would be 3 pi over 2? This asymptote that was at pi over 2, if I multiply it by 3 over 2, I will get 3 pi over 4. And this one, if I multiply by 3 over 2, 9 pi over 4. Similarly, in the negative direction, negative 3 pi over 4. The shape of the graph stays the same. Just our asymptotes and our x-intercepts are going to change their values. The period of this graph, if the period was pi, and we multiplied by 3 over 2, the period is now 3 pi over 2. Again, you can see the period if you took, hey, here's in the middle going up, here's in the middle going up. What's the distance between those 2 points? 3 pi over 2. Or you can measure what is the distance from one asymptote to the other asymptote. That would be 3 pi over 2 as well. And finally, part C. This 1/7 inside would be a horizontal stretch. You would multiply your x values by 7. So we think about our sine graph. Take our period of 2 pi, divide it into 4 equal sections. Amplitude is 1, so we go up to 1 and down to -1. And our sine graph starts in the middle, going up. This is what our sine graph looks like. Now that we have a horizontal stretch by a factor of 7, if our normal period was 2 pi, does it make sense that our period 2 pi times 7 will be 14 pi. And as far as a shortcut goes for graphing this one, what I'm going to ask you to do is pick somewhere along your x-axis and mark one period, which is 14 pi. Because your axis family normally splits something into 4 equal sections, we're going to take this 14 pi and divide it into 4 equal sections. Labeling those 4 equal sections is going to be easy, because what's half of 14? That will be 7. What's half of 7? You can write it as a fraction, or you could write 3.5 pi. That would be fine. That will be 7 pi over 2. And to label the third one, we just count. If this is 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s would be 21 pi over 2. Amplitude is still 1, so our maximum is still 1, and our minimum is still negative 1. When graphing a sine graph will always start in the middle, going up. Here's the middle, going up, maximum, back to middle. Down to minimum, back to middle. And so we can graph our sine and cosine graphs and tangent graphs without showing all the transformations that we did in our previous unit, point to point to point to point. There are some shortcuts for sine and cosine. I would like you to circle questions 3, C, and D. And something I'm going to get you to notice here is that if we have a 1, 7, which is a horizontal stretch, x by 7, your period of 2 pi got multiplied by 7. If there was a 3 inside, your period would get multiplied by 1/3. Okay? So at the bottom of the page, there's a little box with formulas in it. Nope, that's nothing here. Period of a trig function. Okay? I'd like you to write this underneath as well. These formulas aren't on your formula sheet, but if you have a horizontal stretch or compression, you have to multiply by the reciprocal. Multiplying by the reciprocal is like dividing by the b value. So we have a formula for sine and cos that your period will be 2 pi divided by your b value. Later on in this unit, we're going to have to work backwards and take a graph and write an equation. So rearranging this formula, you can solve for the b value. Your b value is always 2 pi divided by the period. Same thing for tangent, but the tangent graph starts with a period of pi. So the period of a tangent graph will be pi over the b value. And similarly, you can rearrange that formula. Your b value of tangent is pi over your period.